what we're going to be doing is we're solving absolute value equations. And so an absolute value is always a positive number because it's the distance from zero. So let us take a look at the first problem. So as you can see, we have the absolute value of -1 plus x, which is equal to 4. Bear in mind that we want to isolate the absolute value ideal. Already it is isolated, which means that we could take this part and let it equal to 4. And this is one case. There is another part where this is also equal to -4 because the absolute value of -4 and 4 is the same. So we have to let it equal to these two things. So let us go. We'll solve this one. So we'll add 1 to both sides, add 1 here. So x is equal to 5, and that's one solution, which means if x is equal to 5, then we'll end up with an absolute value of 4 if we plug it in there. This one, we're going to be adding 1. So x is equal to -3. So the two responses are as follows. X is equal to 5, x is equal to -3. Let us try to see if those really work. Negative, so we're going to substitute. So we're going to substitute 5 here. So let us say we have -1 plus 5. It should equal to 4. So -1 plus 5 is going to give us the absolute value of 4. And the absolute value of 4 is 4. This is true, right? Absolute value of 4 is 4. All right, good. Let's take a look at -3. So if we were putting -3 where x is, we're going to get the absolute value of -4 finally. And the absolute value of -4 is 4. So you could see that these solutions work. So let's look on case number 2. All right, so in this scenario, the idea is that we want to make sure that the absolute value is by itself. So in this case, 4 is there, so the absolute value is not by itself. We're going to get it by itself. So what we're going to do is we're going to take 4. We're going to have to take 4 from both sides of this equation. So now we have an absolute value of 7x plus 6. And this is equal to 1. So what we did was just to get the absolute value to be by itself. Now, after it's by itself, then we want to create the two cases. So here it is, case 1, 7x plus 6 is equal to 1. Let us solve this. We take 6 from both sides. So 7x is equal to -5. Then finally, we divide both sides by 7. So one of our solution is that x is equal to -5/7. The other solution is that I'm going to take 7x plus 6, and it's now going to equal to -1. Let us subtract 6 from both sides. So 7x is equal to -7. I'm going to divide both sides by 7. X is equal to -1. In this case, we're having where the absolute value of 4 plus 2x all over 10 is equal to 1. We want to isolate our absolute value. All right. So we're gonna multiply both sides by 10. So then 10 would have canceled itself on the left side. So we're left with the absolute value of -4 plus 2x. And this is equal to 10. Now at this time, because the absolute value is by itself, then what we could do now is to take whatever is inside, which is -4 plus 2x, and we're going to let that equal to 10. This is our first case. So in solving this for x, we're going to add 4 to both sides. 2x is equal to 14. Let's divide both sides by 2. So x is equal to 7. So this is one of our response that x is equal to 7. In the second instance, we're going to take -4 plus 2x, and we're going to let that equal to -10. Procedure remain the same. We're going to be adding 4 to both sides to isolate the x. So 2x is now equal to -6. Then we divide both sides by 2. X is equal to -3. So the solutions are as follows. X is equal to 7, as well as x is equal to -3. With absolute value inequalities, all we have to do is to make sure we pay attention to details. Whenever we're dealing with the greater than, so this is a disclaimer. If we're dealing with a situation with the greater than, it's always the R. So whether it's greater than or equal to, it's going to be the R, right? So that's the R case. Now, if we're dealing with less than or equal to, it's going to be the AND case. When we speak of the R, we're referring to a union of ideas, so that the ideas will combine. But when we say and, we're only going to be using the part that intersect or overlap. We're looking for the answer, the part of the answers that overlap, because definitely in this case, they're going to overlap. So let us take a look at what's going on. All right, so we have x minus 10. Absolute value of x minus 10 is greater than 7. Now, the absolute value is by itself already. So I could take this part and says absolute, we could just say x minus 10 is greater than 7. And this is our first case. You solve it ordinarily. Now we're going to be adding 10 to both sides. So now x is greater than 17. And this is one of our solutions. The other solution is that, which is the or. We're going to take this, which is the x minus 10, and we're going to have to flip the sign. So we're going to turn the sign now. Remember, we got it like this. We're going to have to change it to that, right? And then it's going to be -7 this time. So because we're going to change it to -7, we actually had to switch the signs, right? So that's one of the things that we have to look out for to both sides. So now x is less than 3. So these are our responses. X is greater than 17, x is less than 3. Now, if I'm supposed to represent this on the number line, this is -infinity, and this is going to be my positive infinity here. 3 is going to be somewhere here, 17 there. What this is saying, right? Because we do not have a bar underneath our inequality, is mean that we're going to have an open circle at 17, and then we're going to point towards positive infinity, going that way. And at 3, we're going to have an open circle as well. But remember, it says x is less than, so we're going to point towards -infinity, going that way. So the responses are in that region. So if we were to write it as interval notation, we would have had from -infinity to 3 union, right? From 17 to positive infinity. Now, in this case, we're seeing where we're looking at the less than symbol. So the absolute value of -9 plus x is less than or equal to 13. This means that our responses will have an and between them. So we're going to be looking for the overlapping section. So whenever your inequality has the absolute value inequality has the less than or equal to, it's going to be an and situation where you're going to have to look for the overlapping idea. So let's solve. All right, so -9 plus x is less than or equal to 13. Adding 9 to both sides, we'll have x is less than or equal to 22. This is one of the response. The other response is going to be -9 plus x. Now I'm going to have to switch the sign and then change this to -13. So we're going to be adding 9 to both sides. So at this time, we have x is greater than or equal to -4. So let us take a look at this on the number line, okay? So on the number line, we would have represented -4 here, and let us say 22 is up this end. -infinity, +infinity. This one says that. So let me put it right here on top. Just going to shade on top of it. So let us say we have it here, making sure that we shade this. And I'm going to point towards less than or equal to 22. So I'm heading that way. Now for this one, right, as you could see, I'm going to shade this because it's the bar is underneath my inequality. And it's greater than or equal to -4. So that means I'm going this way. We're saying here that the solution for this case is where they overlap. And they did overlap between here and here. So the responses we're looking for would be between this interval right here. This is when both of them overlap, as you could see right here. So x, as you could see, it's less than 22, less than or equal to 22, but that same x is greater than or equal to -4, right? So that is the section that we're referring to, right? As it relates to our solution. It's the between these right now. So if you were to put it in interval notation, it's going to be from -4 to 22.